8.1 talks about hypothesis testing. That's chapter 8, basics of hypothesis testing. So goal, make a decision about the proportion or the mean based on the sample proportion or the sample mean using probability. In chapter 7, we find a sample, then estimate. That's what we did, whether the population fits within a certain interval. In chapter 8, given a past claim of a parameter, we will test whether or not it has changed. So 1, make an assumption about reality. So we make a hypothesis about a parameter. That would be either the population proportion or the population mean. 2, look at a sample evidence, that is, find a point estimate to test p hat or x bar. And 3, determine whether it contradicts our assumption, that is, making a decision. If p or mu has changed. So, we won't be 100% certain. We will just be able to tell if the sample data, and this is very important, based on this data, if it supports a statement or not. Nothing more. And every time we're gonna conclude, we're gonna say, based on this data we support, or based on this data we do not support. So, null hypothesis, we denote it by h sub 0. This is old idea. This is how things were. Null hypothesis, this is the new change, new idea. This is always the change. So every time you do the null hypothesis, we're assuming this is a statement of no change. Things stood the same. No effect, no difference, and it's assumed true until evidence indicate otherwise. A statement that we are trying to find evidence to support instead of h naught. So this is what we're trying to do with the alternative. We're trying to find whatever this is not. The null hypothesis assumes the status quo. Whatever happened before, we assume it happened again. The alternative hypothesis, h1, assume a change have happened. And you're testing whether a change did happen or not, but we always based it on the null hypothesis. I'll talk about that when we start looking at examples. And we have 3 types of testing. If they say the null hypothesis, the parameter equal a number, the alternative could be, well, you know what? No, this is less than that number. That's a left tail. It could be the null hypothesis equal a number, and if you have 2 tail, then you say, you know what? It's not equal to that number. Whether it's above or below, it's different. Or you could be looking at a right tail, and that's if the parameter says, hey, this didn't change, the alternative will say, well, you know what? That number did change. Let me separate those a bit. Now things are bigger. So depending on what you're testing, and all of that we're going to practice as we do problems. And here's the first set of problems. It says, what is the parameter? What do they say? What do we think? And what type of test? Well, let's see. The package of a light bulb says it should last 500 hours. So the average should be 500 hours, right? Here we're talking about the mean. Consumer Reports wants to know if the mean lifetime is actually less than that. Well, the null hypothesis, what do they say? The null hypothesis will say, you know what, the average is 500. Things don't change. The alternative hypothesis will say, well, you're trying to study if it's less than 500. So if I'm doing a testing based on this, this is a left-tailed test. Here, the standard deviation of the rate of return for some mutual funds is 0.08%. A manager believes that the standard deviation might be higher. One, we're trying to do the standard deviation for the mutual fund. The null hypothesis will state, hey, don't change. The standard deviation is 0.08%. Based on what the manager believes, that it's higher. The alternative, the new idea is that, you know what, it's bigger than 0.08%. And here, if you're going to draw the test, well, if it's bigger than, then you're looking at a right tail test. And you know what that means once we do problems. And here, according to a Gallup poll in 2008, 80% of Americans felt satisfied with the way things are going in their life. Our researchers wonder if the percentage is different now. Well, here we're talking about a proportion, P, right? So 80% is a proportion. And the null hypothesis will say, hey, what is it? It was 80%. The proportion is still 80%. Look at the wording on the research. The researcher wonders if the percentage is different now. So the alternative, we're testing whether it's not 0.80. And if I draw my, use a different color, different, well, above or below will do. This is a two-tailed test. So we have two possible correct conclusions. If we decide there's no evidence support H naught, you reject H naught. This is if we decide, remember, there's only the null hypothesis and the alternative. If we decide there is evidence to support this, then we reject that. That's correct. Also, we have the null and the alternative. We decide there is not enough evidence to support this. If we don't want to support this, then we must not reject H naught. Here's the catch. Our conclusion is always based on H naught. We can never make the conclusion about the alternative because H naught has the equal, has the actual studies or the numbers that were there before. So either we accept the null hypothesis or we reject the null hypothesis, one of the two. By accepting mean we do not reject. So historically, Jimbo's Pizza had a mean delivery of 48 minutes. After getting a new pizza oven, he takes a sample of 50 orders, so n equal 50. On average, they do 48 historically. And finds that the mean time of delivery now is 45 minutes. So new, 45 minutes. Right? That's based on the sample of 50. which makes Jimbo think that the mean delivery time has been reduced. State Jumbo's hypothesis. The null hypothesis will say, you know what, the average didn't change. It's always 48. That's never going to change. The alternative, based on the sample that he did, he thinks it's going to be less than 48 minutes. And that's how he determines if it's a left hand, right hand, or mid. State the conclusion if the null hypothesis is rejected. If you reject the null hypothesis, you would say there is sufficient evidence to support the claim there is sufficient sample evidence stating that for those 50 that they picked, 50 orders it happened to match, to support, let me read it one more time. There is sufficient sample evidence to support the claim that the mean delivery time is less than, has been reduced. The mean delivery time, it's right there. So you restate what you're trying to test. And what if the null hypothesis is not rejected? We say there is not enough sufficient evidence, sufficient sample evidence to support the claim that the true mean delivery time has been changed. Not to worry if you're not seeing this, because we're going to do that on every single problem. Now, 4 possible outcomes whenever you're making those claims. Example, in a court case, H0, the defendant is innocent. The alternative, the defendant is guilty. Decision based on the sample hour conclusion. If you fail to reject null hypothesis, if the hypothesis is true, right, and you fail to reject it, you have just concluded that the person is innocent. That's pretty good. When in fact they are innocent, that's good. Here you made the right call, and it was the right condition. Here, if you reject the null hypothesis, you are rejecting that the person is innocent. That means you're saying they're guilty, when in reality, right, they were innocent. That's a problem. That means here your conclusion is wrong. This is called a type 1 error. That's when you reject the null hypothesis and it was true. If H0 is false and you accept it, right? So H0 is false and you fail to reject it. That means you're accepting that the person is innocent when in fact the person was guilty. That's a problem. And this is the type 2 error they're going to refer to. And if H0 is false and H0, the defendant, is innocent, if the person is not innocent, they are guilty. And if you reject the null hypothesis, you're saying they are guilty. And either way, we are happy with this. That's fine. So those two are true. This is type 1 error when you reject the null hypothesis and it was true. And this is the type 2 error when you do not reject the null hypothesis and it was false. So you support it. And that's pretty much what this says. Type 1 error. The mistake of rejecting the null hypothesis when it actually was true. alpha is used to represent the probability of such error. We use beta for type 2 error. We're not going to go much in those, only in the beginning. On average, it used to take 30 minutes to find parking, on average. So the null hypothesis will always say it takes 30 minutes to find parking. It never changes. But we think we have sufficient evidence to say that the time has decreased. The alternative hypothesis always go by the new evidence. Right? But in fact, the true parking time is still 30 minutes. What kind of an error would you make? Well, let's see. We think this is true. Isn't that what we think right there? We think we have sufficient evidence that this is true. When in fact, we're rejecting this when it is true. So if we reject the null hypothesis, remember, if you reject the null hypothesis and it was true, that's a type 1 error.